Dr. Anthony Raj. He has pursued his bachelor's, master's and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Thiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to E-lecture series on BSc Electronics Practicals. In this lecture, we are going to discuss how to construct Colpitt's oscillator and phase shift oscillator. Both the oscillators are constructed using transistor. This lecture is going to be organized in the following way. Aim of the experiment, apparatus required to do the experiment, formula used to calculate the theoretical frequency of the experiment, circuit diagram of the experiment, observations made in the experiment, then result. So, this is the organization of this practical lecture. Aim of this experiment: to construct and analyze the Colpitt's oscillator and phase shift oscillator. Both the oscillators are constructed using transistor. Colpitt's oscillator. To construct the Colpitt's oscillator, following apparatus are required: DC power supply, transistor, resistors and capacitors, function generator, cathode ray oscilloscope, multimeter and inductance coil. These are all the apparatus used to construct Colpitt's oscillator. The theoretical expression used to calculate the frequency of the Colpitt's oscillation. F is equal to 1 by 2 pi square root of LC is the theoretical expression used to calculate the frequency of Colpitt's oscillation. Here L is used. So, Colpitt's oscillator is an LC oscillator instead of RC oscillator. L is the self-inductance of the coil used. C is the capacitance of the condenser. Here two capacitors are connected in series, so that the capacitance of the collective capacitance or effective capacitance of the seriously connected capacitors is C is equal to C1 C2 divided by C1 plus C2. Then C1 C2 are the capacitance of the two capacitors in the tank circuit. This is the formula used to calculate the frequency of oscillation of Colpitt's oscillator. Next, circuit diagram used to construct the Colpitt's oscillator. A transistor is taken. That transistor is biased by voltage divider biasing network. Then feedback is given through two capacitors C1, C2 and an inductor coil. So, that will be the tank circuit. Then from the power supply, that is VCC, a resistor is connected to collector terminal of the transistor. Then from the collector terminal, a capacitor is used to get the output signal. So, output signal will be a sinusoidally oscillating signal. By observing the frequency of the output signal, we can compare the theoretical frequency with the practical frequency. That is the aim of this experiment. So, the circuit diagram of Colpitt's oscillator using bipolar junction transistor is shown in this figure. Then this is a RC coupled amplifier using a transistor in common emitter configuration. Resistors R1 and R2 are the two resistors which form voltage divider bias to the transistor. A resistor Re is connected in the circuit which stabilizes the circuit against temperature variation. So Re is the emitter resistor. Then a capacitor Ce is connected in parallel with the emitter resistor Re will act as a bypass capacitor, and this bypass capacitor provides a low reactive path to the amplified AC signal. So the coupling capacitor Cc blocks DC and provides an AC path from the collector to the tank circuit. This is how the oscillation is generated in this Colpitt's oscillator. Then the feedback network, that is the tank circuit, which consists of capacitors C1 and C2 in series placed across a common inductor L. The center of the two capacitors is tapped, that is grounded. So the feedback network C1, C2 and L determines the frequency of oscillation of the oscillator. So the tank circuit exists in the feedback network provides the necessary oscillation in Colpitt's oscillator. So the two series capacitors C1 and C2 forms the potential divider led for providing feedback voltage. The voltage developed across the capacitor C2 provides regenerative feedback, which is essential for sustained oscillations in the oscillator circuit. So in Colpitt's oscillator, the C2 provides the regenerative feedback, which is very important to obtain a stable stable oscillation. Now observations of this experiment can be recorded like this. By varying the inductance, we can by varying the inductance and capacitance, we can get the observed frequency, and calculated frequency can be obtained from the formula, theoretical formula we learnt. So by comparing the observed frequency and theoretical frequency, we can predict the stability of this Colpitt's oscillator. Next, phase shift oscillator. This phase shift oscillator formula is 1 by 2 pi RC square root of 2n. This is the formula to calculate the frequency of the phase shift oscillator constructed using transistor. Here Fr is the output frequency in hertz, R is the resistance in ohms, C is the capacitance in farads, then N is the number of RC stages connected in this phase shift oscillator. Depending on the number of RC stages, the oscillation is predicted in phase shift oscillator. Here we are going to use 3 RC stages in phase shift oscillator. This is the circuit diagram of phase shift oscillator. This circuit diagram consists of 3 stages of RC network, where C value is 0.01 microfarad, then R value is 4.7 kilo ohm. So like that, 3 4.7 kilo ohm resistors and 3 0.1 microfarad capacitors are used to construct this phase shift oscillator. Then tank circuit is connected in the emitter terminal of the BC107. This is the circuit diagram of phase shift oscillator. Here in this phase shift oscillator, we are using BC107 transistor for implementing the RC phase shift oscillator. BC107 is an audio frequency transistor. If we use a common emitter amplifier with a resistive collector load, there will be a 180-degree phase shift between the voltages at base and collector. It will also amplify the signal. This is the phase shift oscillator circuit. Then feedback circuit section must produce another 180-degree phase shift to meet the Barkhusian condition, which is an important condition to get oscillation in an amplifier circuit. 3 sections of phase shift networks are used, which is constituted by resistive capacitive combination. So, 3 sections of RC combination is used to construct the phase shift network. In that 3 section, each section introduces 60-degree phase shift at resonant frequency. So, you will get 180-degree phase shift from the input signal in the output signal. This is how phase shift oscillator is constructed. Then the positive feedback from output to input will lead the circuit to operate as an oscillator. Phase shift oscillator is a particular type of audio frequency oscillator. So, output signal is obtained across 1 microfarad capacitor and ground terminal as shown in the schematic circuit. So, the output from the phase shift oscillator is obtained across 1 microfarad capacitor and ground terminal. So, this is how phase shift oscillator can be constructed. So, in this experiment we are going to construct Colpitt's oscillator and phase shift oscillator. In Colpitt's oscillator, there is no phase difference in output signal. In phase shift oscillator, there is a phase difference in output signal. This is Colpitt's oscillator circuit. This Colpitt's oscillator circuit is constructed using transistor BC107 and capacitors 0.1 microfarad and 0.01 microfarad and a variable inductance coil. By varying this inductance coil, we can see the variation in the output frequency. So, that is the main aim of this Colpitt's oscillator. First, transistor should be biased. So, biasing is done by a voltage divider biasing network. So, this is the positive supply of the power supply that comes to the biasing resistor, which goes to base of the transistor. Then to the power supply, tank circuit is connected. That tank circuit consists of 2 capacitors and 1 inductance coil. Here we fixed the capacitance value as 0.1 microfarad and 0.01 microfarad. Only a variable inductance coil is used. Then output is obtained from the emitter terminal of this Colpitt's oscillator. Then in emitter terminal, another tank circuit consisting of a resistor is used. So, that circuit is used to stabilize this oscillator circuit. So, this is the construction of Colpitt's oscillator. This Colpitt's oscillator output can be analyzed in a cathode ray oscilloscope. This Colpitt's oscillator output can be analyzed using a cathode ray oscilloscope. In this cathode ray oscilloscope, you can see a sine wave as output. Frequency of this sine wave is important. To measure the frequency of the sine wave, we need to calculate the time period of the wave. So, we need to notice the time period knob. The time period knob is in which point, that should be noted down. Here the time period knob is 0.1 seconds, 0.1 millisecond per division. So, each box of this display is equal to 0.1 millisecond. So, how many boxes are occupied by a single wave. That should be noted down. So, for this wave almost 1.5 boxes are occupied by a single wave. So, 1.5 into 0.1 millisecond is the total time period of this wave for 100 millihenry inductance. That time period can be increased by varying the inductance. So, inverse of the time period will be the frequency. Now, the millihenry value is increased, that is it is kept as 200 millihenry. For that 200 millihenry, you can see increase in the time period of the wave. So, if time period increases, frequency decreases. So, this is how for various inductance value the frequency of the Colpitt's oscillator can be studied. By the theoretical expression, in the theoretical formula, we learnt that f is equal to 1 by 2 pi square root of LC. So, as the L value increases, frequency of the wave decreases. That is the theoretical relationship between the frequency and the inductance. Same theoretical relationship is experimentally proved by this observation. Now, I am increasing the millihenry to 300 millihenry. Now, the frequency decreases further, time period increases, frequency decreases further. Now, I am increasing the millihenry to 400 millihenry, again frequency decreases, time period increases. This is how Colpitt's oscillator can be constructed and analyzed. Colpitt's oscillator is constructed using transistor BC107, capacitors 0.1 microfarad and 0.01 microfarad and a variable inductance coil. By varying the inductance of the inductance coil, variation in frequency is observed. Observed frequency is compared with the calculated frequency. This is how construction and working of Colpitt's oscillator is studied. This is a 3-stage phase shift oscillator constructed using transistor. Here 3 resistor capacitor networks are used to produce the phase shift. As we have seen in the theory, each RC network will give a phase shift of 60 degree. So, 3 into 60 is equal to 180 degree. 180 degree phase shift can be obtained from this phase shift oscillator. This phase shift oscillator will give a sine output wave. That sine output wave will not be ascending one, instead it will be a descending one. That means in positive half cycle or in the first quadrant you can't see any initial wave. Only in the fourth quadrant you can see the initial wave. First the wave starts in the fourth quadrant and then it ascends to the first quadrant. This is the speciality of phase shift oscillator. Here also transistor is biased using voltage divider biasing network. This is the power supply, positive terminal of the power supply. From the positive terminal of the power supply, it goes to the base of the transistor. From base of the transistor, one more resistor is grounded. So, that will be the voltage divider biasing network. Then in the emitter you can see a tank circuit which consists of a capacitor and resistor. That capacitor and resistor will act as a stabilizing circuit. In collector, you can see the 3 RC network. Each RC network provides a phase shift of 60 degree. This is one RC network, then this is another RC network, and this is the third RC network. End of the third RC network is given to base of the transistor, and output to the output of the transistor is obtained from the RC network. So that RC network output will be given to the cathode ray oscilloscope. In cathode ray oscilloscope, you can see the phase shifted sine wave. So the main aim of this phase shift oscillator is to produce a phase shifted or inverted sine wave which starts in fourth quadrant of the waveform, fourth quadrant of the waveform. Usually sine wave will start from an origin and ascend in a positive direction, but here you can see a sine wave which is descending and then ascending. That means this wave is 180 degree out of phase from the normal sine wave. That is the main outcome of this experiment. As we have seen in the theory, each RC network will provide a phase shift of 60 degree. So here 3 RC networks are used to get a 180 degree out of phase. If you use 4 RC network, you will get a phase shift of 240 degree phase shift. If you use 6 RC network, you will get the normal sine wave, that is a sine wave which is ascending in the positive direction. So to get a normal sine wave or non-phase shifted sine wave, you have to use a 6 RC network. If you use just 2 RC network, it will give you a phase shift of 120 degree, but here we have used 3 RC network. That 3 RC network provided a 180 degree out of phase phase shifted wave. That is learnt clearly from this sine wave. To do this phase shift oscillator, we are in need of a power supply, resistors, capacitors and a transistor. So using these components, you can construct a phase shift oscillator. Phase shift oscillator can also be constructed using operational amplifier, but here we have constructed using a transistor, where transistor can be used as an amplifier. Here it is used as an oscillator, especially a phase shift oscillator which satisfies the Barkhausen condition. So the output waveform is 180 degree out of phase in this phase shift oscillator. 180 degree out of phase shift is obtained by using 3 RC network. If you use 6 RC network, you can get a non-phase shifted wave which is possible using this phase shift oscillator. This is the breadboard. In this breadboard, you can see horizontal lines which are all connected, as well as vertical lines which are all connected vertically. Here a power supply is used to connect the vertical lines. Then horizontal lines are used to connect simple connections or less number of connections. Here this side all the grounds are connected. So from this point to this point all holes are connected. From this point to this point all holes are connected. So transistor is inserted here. The transistor emitter, base, collector, all the 3 are inserted, and you got the phase shift oscillator. This phase shift oscillator consists of 3 RC network, 3 resistors, 3 capacitors. So, this is that RC network. This RC network is used to produce 180 degree out of phase. This capacitor is used to couple the output signal from the output terminal. This capacitor is used to stabilize the emitter junction of the transistor. Thank you.